Okay, unit one. When I say the word constant, what is a constant? What is a constant? What was that? Something that doesn't change. Mathematically, what don't change? Yeah, what don't change? What do not change? Oh, come on. What is a constant? It's a number. Yeah, it's like 2. 2 is a constant. It is always 2. How about, we're going to skip the Greek right now. How about a coefficient? What is a coefficient? Where do you find a coefficient? Unless you don't know what constant is. Yeah, right now you don't know it. How about a coefficient? Yeah, constant is a number. It doesn't change. Like a number. What is a coefficient? What is a coefficient? Coefficient? I'm going to have to start recording the class.
You're good at recording it?
I switched to all 3. Jacob. Yes. A coefficient is a constant next to a variable. It's a constant next to a variable. Remember, I talked about all it does is it just records the screen and the voice. All right, a variable would be like x, right? A variable. What does it mean to be variable? It can change. It's variable, right? Let's go to some things that. How about what are like terms? What are like terms? What's an example of like terms? Either one would be fine. Yes, sir. 2x and 2x. Like terms, same base, same exponent. Like terms have the same base, same exponent. Right? Like y squared and y squared. Or x to the 14th and x to the 14th. Those are like terms. Let's go to some ones I'm not sure if you know. Do you know what a degree of a polynomial is? The degree of a function. Anyone know what that is? The degree of a function. Like if you saw x squared plus 3. What was the degree of that function? I don't know if it's something that you covered. So. All right. The degree of a function or a polynomial, right? We're studying polynomials today, is the highest exponent. The highest exponent. That's the degree of a polynomial. Yeah. Right. So what's the highest degree on a variable? Will be the 1 on the x, right? So that'd be a first degree function. Yeah, first degree function. Right. So the degree is the highest exponent of a polynomial function. How about a monomial? What is a monomial? Ooh, because mon means 1, right? So it's 1 what? What's another word we use? One nomial? You're close. I'm looking for a very specific word here. Jacob? Well, it could be term. Yes, term. It's a term. It's one term. It's like, a monomial will be like 2, or like x, or 2x, or 2xy. What do you notice about each of those? What are they lacking? They're lacking, I can put an exponent on. What are they lacking? They're lacking addition and subtraction. Because when you have addition and subtraction, that's when you get more terms. So 2 plus x, how many terms are there? 2. 2 plus x plus y, how many terms are there? 3. Terms are separated by pluses and minuses. So terms are interchangeable with a monomial. Right? How many monomials are there in 2 plus x? 2. How many terms are there? 2. And how about standard form? What is standard form of an equation in general? What is standard form of an equation in general? I know you haven't done a whole lot with functions and whatnot. But anyone heard of standard form? So let's say you had something that looked like this. X cubed plus 3x squared plus x. Let's say you have something that looks like that. That is in standard form because what? Because it's an order from biggest to smallest. Standard form is an order from biggest exponent the smallest exponent. That's standard form. The biggest exponent to smallest exponent. There you go. Biggest exponent to smallest exponent. That's what standard form is. So I'm going to go from biggest to smallest. Anyone need a clarification on any of the vocab? What? Degree, that would be the highest exponent. So for instance, looking at the one I wrote down here, what degree is this? It's a third degree polynomial, a third degree function when we get the function. My expectation is that those 1, 2, 3, 4, 5, those 7 words, you should get those ingrained so we can talk about things like math. So you don't be like, that thing, or take, I'll tell you what it is. Take the constant, right? You can't combine it with the monomial because they're not like terms. Right? That's what we're going to be talking about. Right? We got to be able to talk about math with some makes sense. Alright. I have a little chart for you. So what we're going to do, because some of you definitions aren't good enough, we're going to kind of describe here some different things. We're going to describe some different things. Have you guys already done something that looks like this now? No. Okay, generally no, then we're going to do it. Alright, so go ahead and copy down. So these are polynomials. So poly, what does poly mean? Multiple, more than one, many. Poly. So polynomial. So many terms. But it's an undefined amount. So in general, we'll refer to polynomials, and there are 3 special types of polynomials we're going to talk about. We already talked about one of them. That was a monomial. We're going to talk about 2 other ones, just make sure we all have the terminology left. Talk about 2 more, just so we know what we're talking about. And there are 2 ways that we can classify them. We can classify them by their degree, or you can classify them by the amount of terms that they have. But to keep them separate, degree is the highest exponent. Classified by terms, that's the amount of monomials we not. I'm just going to zoom in, and I'll scroll down as we go to each one. Does everyone have the top copy down? Okay, right there. Polynomial, degree, classified by degree, classified by terms. You're still going to see it even when I zoom in. 1, 2, 3, 4, 5, there, 6. Coming at the top. Right, so when you're facing, here we go. All you do is zoom in. All right, for there to be a degree, there has to be a variable. So, what's the degree of it? What would be the degree? Kelsey, I see you going like this, that's correct. The degree here would be 0. There's no variable, you can't have it. So classify it by its degree. So, if there's no degree, what is the number 6? Think back to our vocab. What is the number 6? What? No, there's no variable. It's a constant. So to classify this by its degree, this would be a constant. Now you're going to classify it by the number of terms that are there. How many terms are there? 1 term. That makes it a what? A monomial. All right. So your next one. Negative 2x. What is the degree of negative 2x? What is the degree of negative 2x? That's going to be what exponent is on the x. Which means there's a exactly right. The degree here is 1. You studied them all last year. What is a first degree polynomial called? You studied them all last year. Like 2 months. You wrote them, you graphed them. You're overthinking it. What's the big thing you guys study about? This year we're going to study quadratic. Next year cubic. Your freshman year, your 8th grade year, it was what? What kind of equations did you guys study? Linear, yes, linear. Linear. All right, and classify it by its terms, right? There's 1 term for So, Tyler, what is it? Classified by a term. What is it? And then what's going at the top? 3x plus 1. 3x plus 1. Victoria, what is the degree? Very good. 4x classified by its degree. What is it? It's the first degree with the 1. First degree with the 1. All pattern. There's a 1 here. There's a word right here. There's a 1 here. Then here. All right, there are 2 terms. What is a 2-term polynomial called? Yeah. It's I. All right, let's see if we can bust these last few out here. All right, D, negative x squared plus 2x minus 5. Anna, what is the degree on this one? What's the biggest exponent we see? Does anyone know what a second degree polynomial is called? Yeah, it makes a U, right? It makes a parabola. What do we call those? It starts with a Q. Quadratic, yeah, quadratic. Quadratic. All right, there are 3 terms. Trinomial. All right, the next one. What is the highest degree? Mike, what's the highest degree? 3. And remember what a third degree is called? I'll come back to it. What was that? Q, yeah, Q something. Q bit, yeah, Q bit. And what's the question?
For C, why is it a binomial?
How many terms are there?
Oh.
No, but you gotta keep those separate. Like you have a linear equation that has 2 terms. And you have a linear equation that has 2 terms. All right, and then here there are 2 terms of the binomial. And the last one. What is the highest degree? It says 2x to the 4th minus 7x to the 3rd minus 5x plus 1. So the middle on that last one, what's the highest degree? Anyone knows this word? Always very impressed. No, that's just really short. Okay, it's called a quartic. Quartic. Or tip. Quartic. Alright? And then there are 4 terms. So there's no fancy name for it, we're just gonna call it a polynomial. You can call it a 4, you call it a 4-term polynomial, we can just call it a polynomial. Anyone need a clarification on the chart? Alright. So today's actual lesson is this. What is the rule? We don't write that down. What is the rule for adding and subtracting polynomials? So if you had something that looks like this, 3x squared minus 7, that's one polynomial, plus 3x plus 2. What would you do? What would you do if you solve those 2 polynomials? No one? Oh my god, no. Spoils when you multiply, and we're never going to use that word again. That'd be distribute, and do it later here. Yes? No, you don't add random equal signs. Jacob? You use some order operations. Just combine like terms.
Whoa, oh yeah.
Just combine like terms. That's all you have to do. So, in this case, it sounds like many of you have to write this down up here. What is the rule? It's just combine like terms. Like terms, looking back at your definition. Maya, what are like terms? Look back at your definition. Is what are like terms? Same base, same exponent. When you have the same base and same exponent, when you're combining like terms, what gets added or subtracted? If you're looking at your term, which thing? Which thing gets added and subtracted? Use the language that we just talked about. Up here in this one. What? Yes, sir. Constants are going to get added and subtracted. Very good. And let's go ahead and just make that a square too, so we can combine some more things. Which part of the 3x squared and the 3x squared are you going to add and subtract? The coefficient. The coefficient. So what is 3x squared plus 3x squared? 6x squared. Why can't it be 6x to the 4th? Because they're not being multiplied. Yes, Josh and Noah are both in here, right? They're not being multiplied. The only way that we know how to get x to the 4th is either x squared and x squared is to multiply. Right? When you add them, they don't change. All you do is just add the coefficient. And then negative 7 plus 2 is for minus 5. So you just combine like. Questions on combine like terms? If you combine. Addition. There is 2x squared plus x minus 5 plus x squared plus x plus 6. So what you're going to want to do, you're going to want to get the problem copied down. You're going to want to identify what the like terms are. So the first one, I have x squared and x squared. I have an x and x. I have a constant and I have a constant. So all I want to do is do the indicated operation. It says add, you add. So subtract, you subtract. So in red, we get 2x squared plus x squared. Madison, what coefficient is in front of the x squared? Is a 1. So 2 plus 1 is 3x squared. Plus, in green, you have a 1x and a 1x. 1x plus 1x is 2x. And in blue, you have negative 5 plus positive 6 is plus 1. Ayla.
Why don't you add the exponent on the x squared?
What would you get? If you added them, what would you get? Okay, what's the only way you know how to get to the 4th in the x squared and x squared? So the bases would have to be being multiplied to allow you to add the exponent, correct? But we're adding the bases, which means you don't add the exponent. Questions on this? All right, let's look at subtraction. 2x squared minus x minus 4 minus the quantity 3x squared minus 5x plus 4. Looking at this problem, before a whole bunch of people jump in, could someone tell me the mistake that a bunch of students are going to make? What is the mistake that a bunch of students are going to make? What are they going to forget to do? Chelsea, what are they going to forget to do? Do one. Who mumbled that? What did you just say? Who mumbled it? You have to distribute the negative sign to everything within the parentheses. You have to distribute the negative sign to the positive 3, to the negative 5, and to the positive 3. I don't know. People listening at home, I made it in the trash can. You get 2x squared minus x minus 4. Notice the left side doesn't change. When I distribute on the right side, though, I'm going to get minus 3x squared plus 5x minus 3. Now I'm going to do the same thing I did last time. I'm going to combine like terms. Let's go in red. X squared. In green, you have x's. And in purple, you have some times. So in red, you get 2x squared minus 3x squared. Is negative 1x squared, which is negative 1 squared. In green, you get negative x plus 5x. Once again, there's a 1 in front of that x. So negative 1 plus 5 is positive 4x squared. In purple, you have negative 4 minus 3. Negative 4 minus, yeah, negative 4, you want to go back 3 more, so you get some negative. Questions on the graph? Let's multiply. Multiplying. We are only going to multiply monomials and binomials for this course. So just monomials and binomials. All right, let's go ahead and try those. Go ahead and try those. So it's easy. Tia, what is 3 times 7? 21. Very good. 21. What is 3x times 7? What is 3x times 7? Danny, what's 3x times 7? 21x, yes. And what is 3t times 7x? What? So 3t times 7x. Follow the pattern. Follow the pattern. 21xt or 21tx or t21x or xt21 are all good. 21xt. You just multiply things you can multiply. Go ahead and multiply those. That says 3 times the quantity, x plus 4, and 3x times the quantity, x plus 4. So 3 times the quantity, x plus 4, and 3x times the quantity, x plus 4. You, number one favorite property, that for whatever reason you know very well, you are going. Oh, don't call me. No, you know the easiest way to remember it is? Distributive property. That's by far the easiest way to remember it. Because every student knows that. Kate, what do you get when you get, what do you do here? Wasn't that great language? Okay, what do you get? 3x plus 12. And the second one, when you distribute in black, what did you get? Stephanie, what did you get? What is x times x? So 3x squared plus 12. 3x squared. And the last one, the binomial. X plus 3 times x plus 4. X plus 3 times x plus 4. X plus 3 times x. When anyone beats those, oh my god, do not say FOIL. You distribute. That's all you do. You only distribute. That's all it is. Kelsey, to distribute this properly, can you please explain to the class how to distribute this properly? I don't know what that means. What is this x right here? Oh, Kane, yes. Oh, that was so much better. I know exactly what to do. Okay, what is x times x? Bethany, what's x times x? What is x times 4? Morgan, what's x times 4? 4x, very good. Therese, what is 3 times x? Good? And Olivia, what is 3 times 4? Alright, what is the last step that I need to do in this problem? Ayla? Very good. Right, you want to combine like terms. So, we get x squared plus 7x squared plus 12. Yeah? No, what's wrong with that? You just add the coefficients. It's just 4 plus 3. You don't add and get x squared. Alright, so it's just x squared plus 7x plus 3. What? Unless you're multiplying. Are you multiplying the 4x and the 3x? No, you're adding them. You just add the coefficients. Questions, comments, concerns? Alright, that's lesson 1.